Okay, Matrix, let's look at the concept of what we call inverse functions. Okay, inverses of graphs. Okay, and we call them inverse functions, inverses of graphs. Okay, now what do we mean by this word inverse? Okay, not a problem. Let's explore this a little bit. What I'm going to do is I'm going to take a specific example. If I take y equals 2x plus 4. If I take y equals 2x plus 4, we can also call this fx is equal to 2x plus 4. Now I want you to hold on to that. We've got y equals 2x plus 4. The idea, very simply put, of getting an inverse of this graph is what we do is we interchange or swap the x and y around. Okay, now this is the graph of f. Now by doing this, we then create a new graph which is called the inverse of this graph by swapping the x and y around. Y becomes x, x becomes y. Now if I rework this, have a look here. If I say negative 2y is equal to negative x plus 4, so you swap those around and then divide both sides by negative 2. So in other words, this would be negative 2 over negative 2, negative x over negative 2, and 4 over negative 2. I get y is a half x minus 2. So this, and we call this graph, this is quite interesting, this is referred to as, if this is the graph of f, this is called f negative 1. In other words, it's the f of negative 1x is going to be a half x minus 2. Okay, equals a half x minus 2. A bit of new notation there. And we want to sketch this graph. So let's have a look at this. If we're going to draw these graphs, how would we sketch them? So the question is, how do we sketch these graphs? Well, very simply put, have a look here. If we take the first graph, if we take, for example, y equals 2x plus 4, and we've got y equals a half x minus 2. The trick with this is to get the y-intercept first by letting x be naught. Y-intercept, let x be naught. This is from grade 10 days. So if the x is naught, what would this give us? Y is equal to 4 if x goes naught. And likewise, y will be negative 2 if x goes to naught here. And this would be your y-intercept here of this graph, and the inverse graph is negative 2. Remember, this is f, and that's the inverse. These guys are each other's inverses. Okay, by simply swapping x and y around. The x-intercept, what are we going to do there? We let y be naught. X-intercept, we're going to let y be equal to naught. So here, if the y becomes naught, it's 2x plus 4. If the y becomes naught, it's a half x minus 2. Okay, now if we bring this across, the negative 2x, we have it on the left, we have that equals to 4, and we divide both sides by 2, the x-intercept would be negative 2. This one, if you bring the half x across, we get this. Okay, you can of course multiply both sides by the negative if you want to, and of course if you simply multiply both sides by 2, you can get x is equal to 4 there. Alright, and that is going to be your, again, your x-intercepts there of this graph. There we go. Okay, so, and then the very simple thing now is we're going to draw these graphs by plotting these points. So I'm going to draw a set of axes, and let's talk further as we go along. Okay, now have a look at this, guys. We've got a set of axes here. Now let's plot these points and see how it goes. Alright, here we go. I'm going to use some color here. Alright, if you look at the first graph, what do we know? Okay, for this one, 2x plus 4, y-intercept 4, x is negative 2. So the x is negative 2 there, and the y is 4, and that's the graph of f. Alright, and what is that graph? Y equals 2x plus 4. Now this one, now notice, this is actually 0, 4. So if you swap those around, you get 4, 0. And if this is negative 2, 0 here, and you swap that around, you get 0, negative 2. Now this is the graph of the inverse, which is a half x minus 2. Look at that, isn't that amazing? What's interesting about that, so once you've plotted your point y is negative 2 and x is 4 for the inverse graph there, watch what we've got. We've got these swapped around. But notice also, there's something very interesting. If you take that point and that point, and if I had to fold this page across this line, and this line is y equals x, the graph of f and its inverse would be reflections about this line. How do we get this line y equals x? Well, very simply put, if x is 1, y will be 1. It's exactly the same. If x is 2, y is 2. There you can see there. Very simply put, x is 2, y is 2. So this is the graph of y equals x, because the y becomes x, x becomes y. You've interchanged the x and y around. They're each other's inverses, the reflections about the line y equals x. And if you've got the graph of f, if that's 0, 4, the other value is 4, 0. If that's minus 2, 0, the other value is 0, negative 2. What a pleasure. And there we go. That is the graph of the inverse of 2x plus 4. I think it's time to look at another example quickly, just to make sure that you fully understand this. Have a look at another one. How about this? Say, for example, I said to you, sketch the graph. Here is it. fx is equal to 3x minus 6. You need to express this graph as its inverse. Okay, so if we look at y equals 3x minus 6, there's the graph of f. If you swap the x and y around, you will get its inverse. Okay, and now let's work this. Negative 3y, bring that across. Negative x minus 6, divide everybody by negative 3, and we then land up getting that, a third x plus 2. And that would be the inverse of that graph. Okay, so if we bring it down, let's have a look here. Again, we've got the graph of f, and we've got the graph of its inverse, f negative 1. Remember, you can write it in this form as well. F minus 1 is 1/3 x plus 2. That's in the fx notation, or the inverse notational form. So let's draw these graphs. Y equals 3x minus 6. Let's see, y is 3x minus 6, and the other one is y is 1/3 x plus 2. Okay, what would be the y-intercepts for these guys? We let x be 0. So in this case, y would be negative 6, and in this case, y would be 2. Y-intercepts for this graph of f, and for the inverse, we've got this one. How do we get the x-intercepts? Well, we let y be 0. So in this case, y is equal to 0. Okay, and here y is equal to 0. Okay, this gives me 6 is equal to 3x if you bring the minus 6 across, and x is equal to 2. That's going to be your x-intercept there. If you do this, you could bring the negative 2 across if you wanted to, and then we simply multiply both sides by 3 to get rid of the fractions. Negative 6 is x, and there, of course, is your x-intercept. Now let's draw the graphs of these functions, and let's see what happens. The functions, by the word, is another word for graph. Okay, but there's something unique about a function which I will talk about in a moment. Here we go. Let's draw these graphs. Okay, here we go. I've got some graphs drawn up there. Let's look at the first one. 3x minus 6, y-intercept negative 6, x is 2. Y-intercept negative 6, and x is 2. Okay, so let's see. X is 2 and y is negative 6. So there we've got negative 6 here and 2 over there. Let's just double check that. So x is equal to 2, y is negative 6. Now remember, this is the point 2, 0 for this point there. That's the graph of f. Okay, and then you've got 0, negative 6. Now if you swap this around, you're going to get 0, 2. And that's going to give you your inverse graph. And this will give you, if you swap that around, minus 6, 0. You see that there? And look at this. If you go and check this, it's interesting. The y-intercept is 2 and negative 6 for the inverse graph. Remember, this is y equals 1/3 x plus 2, and this one is y is equal to 3x minus 6. And this is the line y equals x, and they are reflections about this line y equals x. Look at that. Isn't that amazing? The x and y are interchanged, and there you go.